Hello friends, how are you? Hope everybody is fine. This is your teacher Bharat sir, and as we discussed in the my second video that is related to relations, we will extend that theory further, which goes to the 12th class. So let us first have a quick recap of what we have read in the my earlier video, that is my second video. So what we read over there was what was the relation, definition of relation. So if A is a non-empty set, then any subset of A cross A is called relation. So this was the definition of relation, right? So let us repeat it again. If A is any non-empty set, then any subset of A cross A is a relation, and this can be depicted as R is a subset of A cross A. One thing. Then we read what is called empty relation. Now empty relation is generally the empty is denoted like this phi. So we can write empty relation as R is like this curly brackets. There is nothing in the curly brackets, or R is equal to phi. And phi is known as the empty relation. For example, let's take an example over here. If A is 1, 2, 3, suppose there are 3 elements in the set A, and I say R is a relation A comma B such that A comma B belongs to A and A plus B is equal to 10. Can we get any pair whose sum is 10? If I write A cross A, this is given as 1 comma 1, 1 comma 2, 1 comma 3, then 2 comma 1, 2 comma 2, 2 comma 3, 3 comma 1, 3 comma 2, 3 comma 3. So we see that in all ordered pairs, the sum is never equal to 10. Maximum it is equal to 6. So this relation is an empty relation. So R is equal to phi over here. So this is an example of empty relation. Now in the last video we also read about universal relation. What was that? It is just a quick recap. So we are just repeating the same thing, but it is a must before starting further. So universal relation is having all the subsets, means are all the ordered pairs, such as written over above, that is 1 comma 1, 1 comma 2, 1 comma 3, 2 comma 1, 2 comma 2, 2 comma 3, and 3 comma 1, 3 comma 2, and 3 comma 3. That is relation in universal is a relation in which R is equal to A cross A, right? And we also know that R is a subset of A cross A. That is, all relations are the subset of A cross A. That is the Cartesian product of A. So this was done earlier. Now let us come to the important relation which we left at that time, that is called identity relation. Now what is identity relation? Identity relation is generally denoted as I. Suppose it is a relation on A, so IA. This is given as A comma A such that or you can say for all a belonging to capital A. We write like this also, a comma a. For all is this symbol v, and then there is a line, a belongs to capital A. For example, if I take an example, suppose a is equal to, again I take the same example, 1 2 3. So identity relation is 1 comma 1, 2 comma 2, 3 comma 3. That means the first element and the second element should be same, and only those ordered pairs are there in which the first element and second element is same. Now we extend our this journey of relations to class 12. As per CBSE, there's second chapter in class 12th named as relation and function. So in this video we will be doing only relation, and then obviously we will be bringing videos on function also. So according to this chapter, it says that there are 3 types of relations. Number 1 is called reflexive relation. Number 2 is called symmetric relation. And number 3 is called transitive relation. Now one by one we will understand what these relations means actually. Now reflexive relation, what is reflexive relation? If I say mathematically, a relation is a reflexive relation if and only if a comma a belongs to R for all a belonging to capital A. I'll explain this also. Let me write the respective definitions of all the 3, then I'll come one by one on each. And symmetric relation, a relation is called symmetric relation if and only if, right? If and only if a comma b belongs to R implies that b comma a belongs to R. Or I can also write like this, a is related to b implies b is also related to a. We will take one by one each, and with further examples it will be illustrated. Now what is transitive relation? Suppose I say a comma b comma c, a comma b comma c belongs to a, and a comma b belongs to R, and b comma c belongs to R. R means a relation. Then the relation is called symmetric relation if a comma c belongs to R. Then R is called transitive relation. Okay, so this is the basic definition of relations, types of relation, that is reflexive relation, symmetric relation, and transitive relation. Spelling over here, transitive relation. Now let us take few examples, then it will be very clear to all of you that what exactly these 3 relations means. Suppose I say, let me take an example. We will take few examples. Example 1, let A be the set of triangles. There are triangles in set A in a plane, in any given plane. And R is the relation. R क्या relation है? What is the relation? Is similar to on set A. That means A is a set of all type of triangles, and R is a relation similar to. That means that only those triangles we will take which are similar to each other. So if I say it is a reflexive relation, is it correct? Now question arises, how it is a reflexive relation? We know that every triangle is similar to itself. Every triangle is similar to itself. That is, A is related to A. Suppose A, small a represents a triangle. So A is related to A because every triangle is similar to itself. Hence, it is a reflexive relation. Now we come to whether it is a symmetric or not. Symmetric relation. Now, if there is a triangle A and I say A is related to B, that is A is similar to B. A triangle is similar to B triangle. Then obviously B will be similar to A. That is, this implies B is related to A. So if there are two triangles, A is related to B, that is A is similar to B, then B will be also similar to A. So therefore it is a symmetric relation, because by definition if A comma B belongs to R, and this implies that B comma A also belongs to R, so we say that it is a symmetric relation. Now let us come to the third one, that is transitive relation. Now if there are three triangles, say A, B, C are the three triangles, and A is similar to B and B is similar to C, then obviously A will be similar to C. So A comma B belongs to R, that is A and B are similar triangles, and B and C are also similar triangles, B comma C belongs to R, then we can easily say that A comma C also belongs to R, that is A is similar to C. Hence, this particular example, we saw that it is a reflexive relation as well as symmetric relation as well as transitive relation. Now let's go to another example. Example 2. Suppose I take set A be the set of let us take A be the set of all straight lines in a plane. All straight lines in a plane, and R is a relation, R be the relation. Now obviously the relation between the lines, क्या relation है, is perpendicular to each other or perpendicular to on set A. Then is it a reflexive relation? Is the line 1 is perpendicular to the line 2, or you can say line is perpendicular to itself? No. So it is not reflexive relation. Why not reflexive relation? Because a line cannot be perpendicular to itself, right? So it is not a reflexive relation. Now symmetric relation, whether it is a symmetric relation? Yes, it is symmetrical relation. Symmetric relation, it is symmetric relation. Why? Because if line L1 is perpendicular to L2, then this implies that L2 is also perpendicular to L1. So if L1 comma L2 belongs to R, then it implies L2 comma L1 will also belongs to R, right? Now let's talk about the transitivity, or whether the relation is transitive relation or not. This is a tricky one. So suppose there is a line L1. Let me make, this is line L1 and there is another line L2. So L1 comma L2 belongs to R, obviously, because L1 is perpendicular to L2, because L1 is perpendicular to L2. Now suppose there is another line, third line. Let me draw a third line also. Suppose this is a third line. This is named as L3. So L2 and L3, they also belongs to the relation R, because L2 is perpendicular to L3. Now what about L1 and L3? Are they perpendicular? No, rather they are parallel to each other. So we say that L1 comma L3 does not belong to R. Hence, this relation is not transitive. This relation is not transitive. So in the earlier example, the example 1, we saw that all that relation was reflexive, symmetric and transitive. But in example 2, we saw that the relation is not reflexive, but it is symmetric, and also it is not transitive. Yes. So now let's take another example so that the things are more further, it is clear to us, because till the theory is clear, we will not be able to do the actual problems. So our focus should be that our theory should be as strong as possible. Then obviously we will be doing lot of questions that becomes easy then. Now suppose I take another example, and I take A be the set of all real numbers, and R, let me define R, that the relation is less than or equal to, this can be depicted as like this, less than equal to on set A. So whether it is reflexive, how to know that A comma A belongs to R? Yes, because A is equal to A, because we have equal to also, right? See, we have written equal to also. So A is equal to A, yes. So it is a reflexive relation. Now symmetric one, whether it is a symmetric relation, suppose I say 1 comma 2 belongs to R. Yes. Why? Because 1 is less than equal to 2, 1 is less than 2. Let me remove 2 equal to also. So is it correct? 1 comma 2 belongs to R? No, because 2 is not less than 1. So we will say that it does not, 2 comma 1 does not belong to R. Hence it just a minute. hence it is not symmetric relation. Now come to transitivity or transitive, whether it is transitive or not. Sometimes we write the transitivity like that also. So transitive relation, suppose A comma B belongs to R and B comma A belongs to B comma C belongs to R. So obviously this implies A is less than equal to B, and this implies B is less than equal to C. From 1 and 2, can we say that A is less than equal to C? Yes. Hence, yes, sorry. Hence, A comma C belongs to R. Therefore, the given relation is transitive. Therefore, the given relation is transitive. Therefore, the given relation is transitive. Now, let's take another example. It will be example number 4. Example number 4 says, suppose there is a set A given by 1, 2, 3, say up to 14, and there is a relation x comma y such that 3x minus y is equal to 0, where x comma y belongs to A. Obviously x comma y belongs to A, and we want to find, and the relation is on A. When I say relation is on A, that is, we can depict like this: relation A to A, right? So relation is on A. So what we have to do, we have to write the relation in the roster form. Roster form means all the ordered pair. Okay, this is written as set builder form. Set builder form. I hope this is known to you because we have read it in the chapter of sets in 11th class. So I am not going to repeat that. So roster form. Now what is roster form? If I write, that is in the ordered pair. So we can write y is equal to 3x. Keep putting the value of x from the set A, and we can write the relation like this: if x is 1, y is 3, 2, then it is 6, because 3 into 2 is 6, 3, then it is 9, 4, then it is 12. Can I write 5 comma 15? No. Why no? Because 15 is not in the set A. So we have to delete this one. So the final is 1 comma 3, 2 comma 6, 3 comma 9, and 4 comma 12. I'll close it over here. Let me delete this. So is it a reflexive relation? Reflexive, let me write in the short form. Okay, reflexive relation? No. Why no? Because it is a relation is reflexive only if it has 1, 1, 2, 2, so on up to 14, 14. Up to 14, 14. These must be there: 1, 1, 2, 2, so on 14, comma 14. This has to be there, other may or may not be there. So since these are not there, so it is not a reflexive relation. Even if these are there, and suppose I say 14 comma 14 is not there, then again it is not a reflexive relation. All the ordered pairs, the ordered pairs should have the first element same as the second element, and all the elements of A should be there. So it is not a reflexive relation. Is it symmetric? Now if say 1 comma 3 belongs to R, is 3 comma 1 belongs to R? No, it does not belong. So again, it is not a symmetric relation. Now what about transitive? transitive relation. Now 1 comma 3 is there, it belongs to R. 3 comma 9 belongs to R. Does it mean that 1 comma 9 also belongs to R? No, it does not belong. There is no 1 comma 9 in this. So it does not belong to R. Hence, it is also not a transitive relation. So till now, we tried to understand the three important relations, that is reflexive, symmetric and transitive. It is very important as if we consider it as CBSC and in boards, number of questions comes on this topic, and obviously there are a lot of questions to be practiced upon. Now before winding up this video, now we started with the identity relation, right? And now somebody may get confused ki what is difference between identity relation and reflexive relation. Identity relation and reflexive relation. I make sometimes spelling mistake, so forgive me for that. Relation. See, identity relation is a reflexive relation, but vice versa is not true. So identity relation is a subset, you can say, subset of reflexive relation. Again, I'll repeat. Identity relation is a reflexive relation, but vice versa is not always true. Why so? Why I have written this? Let's take an example. Suppose A is equal to 1, 2, 3. We will take simple example, and identity relation will be 1, 1, 2, 2, 3, 3. And what about reflexive relation? There can be number of reflexive relations. One of them is, suppose I put R1, 1, 1, 2, 2. This has to be there, 3, 3. So this is one reflexive relation. Another reflexive relation, 1, 1, 2, 2, 3, 3, and then I write 1, 3 or 1, 2. So this is another reflexive relation. I can write another reflexive relation, 1, 1, 2, 2, 3, 3. Important point is 1, 2. Important point is 1, 1, 2, 2, 3, 3. These should be there. Rest may or may not be there. But in identity relation, only these three are there. If we write the another one, some other pair like this 1, 3 and 1, 2, then it does not remain identity relation. This is the basic difference between identity relation and reflexive relation. So identity relation in general we call it is as a subset of reflexive relation. So I hope students you got some clarity of this topic, and in my next video, in my coming videos, obviously I will be taking few more examples, and especially those examples which has been coming in the boards also. And before winding up, let me tell you one very important point, otherwise I will forget, and that is called equivalence relation. Equivalence relation. Now what is equivalence relation? If a relation is, let me write the definition, if the relation is reflexive, symmetric, transitive, means all these three relations, transitive, then we say that the given relation is an equivalence relation. So in exams, they give problems like that. Prove that whether the given relation is equivalence or not. Then what you have to do, that you have to find whether it is reflexive, symmetric, and transitive. If it is all the three, then we say that it is an equivalence relation. So in my next class, I will be doing some more problems in which we will explain further the equivalence relation, how exactly we have to do. And also there are topics like how to find the number of reflexive relations, number of symmetric relations, like this. So we will be doing these in our next coming video. Please uh, follow this and subscribe, obviously, then only you will be able to get the information. So like the my video, this gives me motivation, and my only aim to make these videos are just to help my students, and whatever knowledge I have gained throughout my life, I should be able to share it with you. There is no other motive. So if you like and share and comment on it, I will be very grateful to you. Thank you so much. It has been a wonderful journey till now, and I hope that it will keep on continuing. Thank you so much. Looking forward to see you again. Bye bye. Goodbye. God bless you all.